You guys remember doing this with old video cameras and a TV screen that used to sit around your house? Well, this is kind of reminiscent of that. Alright, this is the best possible way I can explain the way that the door rendering system works in this game. You start by rendering the entire scene. Now, the scene might look something like this. Normally the camera will take everything in the screen and draw it right there, including the walls, the door, everything else. However, the way that the doors work is that where we would normally draw the blank wall, face, or anything else behind the door, instead what we do is we draw what are called empty pixels. Now, these are pixels with an alpha value of 0. What's an alpha value? Well, RGB values. That stands for red, green, blue. We can shift red, green, blue values to add different amounts of the primary colors into a specific color palette to affect the way that the color looks. So within some specific value of RGB values, we can make something look a little bit more red, or we can make something look a little more green or blue, and we can get anything we want on this color wheel. In addition to that, we have another value called alpha. Now, what alpha allows us to do is it allows us to make the color not as vibrant. And this is exactly what you can see me doing with this door right here. I've cut out everything underneath this door, and it's currently rendering to a transparent layer. So, if I were to take this layer right here and just draw some swirls back and forth on top of it, if I put the layer of the door back on, you'll be able to see the layer underneath it. This is very similar to what I have going on in the game. What I'll do is I'll draw a door. Then I will, in effect, cut out everything behind the plane where the door is, and I'll do some more rendering. Now, what we want the infinite renderer to do, eventually, is notice that we have empty space here. It will reposition the camera and do another render call. If we run into another door, we will do the exact same thing. Cut out another little subsection and draw the next layer down. And we can keep doing this as many times as we want to until we hit what's called our base case. Now, one potential problem that this has is that every single time the render function is called, we draw a complete picture. So, what we start with is the first door, and before we draw everything else around the door, we notice there's this tiny little section where there are no pixels. So what we do instead of drawing this is we go one layer down and draw that one first. But we'll keep going all the way down the list to the fourth one, and then back to the grass. So what we'll end up doing is drawing the grass first, and then on top of that we will draw our next door, and then the door on top of that, and the door on top of that. The problem with this is twofold. One, it requires us to do 4 completely separate draw calls. Notice that all of this area outside of the door is never even used, but our computer will go through and render every single line individually. And notice that every single one of these parts of the door will not be used when we throw another layer on top of it. Now, this entire wall space and this part will not even be used. And we can even see that happening again when we layer a door on top of that. And this becomes especially tragic when you consider that a space right here, this pixel might get rendered up to 4 times. So, what do we want to do? I would like to be able to take this door and be able to tell the camera underneath it, hey, I only want you to render this area. Since that's the area that I care about rendering, we could tell the next camera down that we only care about this area. Don't even worry about drawing anything else, so that it only draws what's inside of this. Then, we can tell our next layer down that we really only care about it drawing this area. In a perfect world, we would get all the way down to the center here and only tell it that we need to draw this area. So in effect, as we go back up the stack, what the camera would do is that we'd start at the bottom and only draw this, and then we would draw this on top of that, and then finally the entire image. So we only draw each pixel only once. This of course is great for performance reasons, but in addition to that, there's another great reason to do this. This is the other reason why this would be beneficial. Take a look at these two doors. We've got one on the right and one on the left. Now, if we take two doors and do recursive rendering on each of them, we'll notice that we can draw this one and then this one. However, depending on which layer and order that these two come in, we may find that one completely covers the other. If you take a look at the base case, if we draw this door, and then we also draw this door on top of it, there's no buffer cutout over here from this camera. So it draws over top of this other door, which means that this door does tile nicely, but this one will not. We can change the ordering on this, but the effect will be exactly the same. Whichever door renders first will have priority. However, if we were to cut the layers out, we would be able to see both doors at the same time. Here's a perfect example of what I was talking about earlier. On the left you can see me rendering through the left side, but then it switches to the right when I stop rendering that one plane. This is a perfect example of the two doors scenario. In the end, I still had a different problem that I had to solve first. I was only rendering about one camera layer deep. You can see there's only 2 red squares and 2 green squares. That's because we're rendering the first door, and then we're rendering what's behind it, but it would quit immediately afterwards. And it took me a long time to figure out exactly what was going on with this. I tried messing around with a couple of other things, including this, render texturing. This is very common when you want to make a mirror effect, which is similar to what we're doing here, but not quite. The foreground will approach twice as quick as it ought to, and it just doesn't look right. In the end, the solution that I was looking for was to allow the cameras to exist in the scene for longer than they should, or longer than I originally thought they should. What I was doing in the past was immediately deleting the camera after I would instantiate and render it, but that wouldn't give it enough time to draw on the screen. So, if I leave it to exist a little bit longer and simply shuffle the cameras around and reuse them, then they have time to render onto the screen. This was about all that I had time to do this week. Unfortunately, it wasn't quite a lot, but hopefully during the next week I'll have something more interesting to show off. Thanks, come back again.